finish chapter 6 pretty much probably tomorrow. It's just percentages basically. That's all that's in chapter 6. 5 is all decimals, 6 is all percentages. We may end up covering a little. We may have to end up covering a little bit of stuff on Monday, but I'm pretty sure we'll finish this week because we have your next test coming up next Tuesday, if I'm not mistaken. Pretty sure. So your test is next Tuesday. Normally I try to put them on Thursdays. It just didn't work out this quarter, so I had to go on a Tuesday. But the practice test is already out. You know, it's in the modules. You can find it under all the Chapter 6 stuff. So it'll just cover Chapters 5, 6. So over the weekend, between now and next Monday, just make sure that you're taking a look at the practice test, just so you kind of get an idea of what types of questions will be on the exam. Yeah? And it's not like, so it doesn't cover 2 through 4. It's not cumulative in that sense. It just covers the past 2 chapters we covered. So all the decimal stuff from last week and the week before, and then all the percentage stuff that we're doing this week. And that'll be it. Any questions about that? About the exam? Yeah.
We have the exam on the 25th.
Is that? Am I a week ahead?
Yeah.
Wait. Oh, maybe I'm okay. Oh, okay. I might be off. Yeah. Okay. I'm like. I know it's on a Tuesday, right?
Yeah.
Oh, maybe we're way ahead then. I don't actually know anymore. I'm confused. Oh, because we have that weird 2-day week next week, huh?
Yeah.
Oh, that's right. Okay. Okay, that's way better. Because I was thinking about it, and I was like, I think we could finish it all by tomorrow. But then I was like, anyways. So never mind. We don't have a test next Tuesday. I was a week ahead of myself. I forgot next week existed. We have no class next Monday, and then we have 2 days of class. And we actually don't have class next Thursday either. That's the CBC is closing their campus for the day that day for some stuff that they're going to make us do. Anyways. Okay, never mind. Thank you for bringing that up. All right. Forget everything I just said. Test on the 25th. Yeah, there you go. I go by the calendars just as much as you guys. I don't really plan that far in advance. I'm not really a big advanced planner. I usually pull it up once a week just to make sure we're on the right track. All right. So with that in mind, that gives us a little bit more time to deal with percentages, which is good. Because some of these percentage problems can be tough. So, any other questions about, since we don't have the test next week, I guess you probably don't have many questions about that yet. All right. So, so yesterday we talked about how percentages mean literally like per 100. So if you're trying to convert between notations, so the examples, we didn't go over any of these yesterday, right? I didn't think so. So some of the examples I gave you, jeez, man, this thing is mad at me. All right, that'll work. So like I gave you 24%, right? So if you wanted to convert 24%, sorry, I'm trying to figure out what's going on with my thing here. What do you do with it? Yeah, you just put it over 100, right? Because percentage is per 100 is literally just hundreds. So 24% is like 24 hundredths. Of course, you should reduce it if you can. So like both of these are divisible by 2, but also 4. So I might go straight to 4. And I think that one will reduce to 6 over 25. Yeah. If you have a decimal in there, like 2.7%, it's still the same idea. You just slap it over 100, but then you don't usually keep decimals inside of fractions. So we would want to move that decimal place over one place value so that it's no longer a decimal. But if we do it in the numerator, we also have to take this decimal that's at the end of 100 and move it along with it. So if you're going to move decimals in the numerator, that's fine. Just make sure if you do it, you also do it in the denominator. And so this would come out to be 27 over 1,000. And you can always check these, right? It's kind of nice because you could always just take the fraction that you end up with and do the division and make sure that it comes out as the decimal form of the percentage. It'll always work. I don't think that's reducible. You can have percentages that come out over 100. So that's fine. It's just going to create an improper fraction, which is also fine. There's nothing wrong with improper fractions. So then here, if you reduce this one, this would be 155 over 100, divide both by 5 at least. So 155 divided by 5, I think, is 31. Is that true?
Yeah.
And then 100 divided by 5 is 20. And I think that's probably as far as you're going to be able to go. I'm pretty sure 31 is prime. I don't think it's divisible by anything. So, all right. If you run into decimals, so like 0.45%, if you wanted to turn these into fractions, well, it'll just be 0.45 over 100. In this case, how many places does a decimal need to move? In this case, I need to move it 2 places to get rid of that decimal. But then I'm also going to have to take that decimal after 100 and move it 2 places. So it would be 45 over 10,000. And those are both divisible by 5. So that 45 divided by 5 is 9. And then 10,000 divided by 5 is 2,000. So that would be the fraction forms of those. Okay. If you wanted to turn these into their decimal forms, what would these? I think I did actually ask you to do them both on the practice there. If I wanted to write that as a decimal, what would 24% be? What's the trick? You could do it both ways now. I mean, it's already a fraction, so you could just pull out your calculator and you could just do 6 divided by 25. But if you did that, what are you going to get? You're just going to get 0.24. But we could have known that originally, right? So 24%, we would just be taking that decimal and we would just be moving it over 2 place values, right, to turn it into its decimal form. Same thing with the next one. If we wanted to put it into decimal form, you could pull out your calculator, do 27 divided by 1,000, but really all you need to do is go back to the percentage and just move that decimal over 2 places, so it would be 0.027. That would be the decimal form. What about 155%? It went to 31 over 20, but as a decimal, what would it be? 1.55. Right. 0.45%, if we wanted to turn it into decimal, you could just take 9 divided by 2,000. That'll work. But it'll just come out to be 0. We move that decimal over 2 places, 0.0045. Okay. So there's always 3 forms that percentage. So you got your percentage, right? You got your percentage display. You can convert them into fractions by putting them over 100 and reducing, or you can write them as decimals. And the decimal is the more common way that we deal with percentages in math. Fractions can be useful some ways. Decimals are more common. All right. Okay. Any questions on any of those? How any of those came about? Perfect. So then I gave you some working the other way. If I give you the decimal, so like 0.14, how do I turn that back into a percentage? Yeah, it's always 2 decimal places. In this case, though, we're starting with a decimal, so we need to go the other way. This will become 14%. Right, the percentage is always bigger than the decimal. The net, I gave you another one, was 0.875. It's always 2 places. So what's that going to be? 87.5%. Yep. If the decimal, we already did this one, 0.0045. If we kick it back, 0.45%. Right, it's always 2 places. And then if it's if it's a whole number, what's going to be true about our percentage? It's going to be big. It's going to be, that's 230%, yeah. So. Yeah? Okay. Then if you wanted to go, and then the last part I gave you is just some practice of going fractions to percentages. So like if I have like 1/4, then the easiest way to turn that into a percentage is first put it into its decimal form, right? So 1/4, you do 1 divided by 4, you get 0.25. And then you can move that decimal place over to get it back into its percentage, right? So 1/4 is 25%, which most of you guys we already knew that. Okay. I gave you 3/8. So if you take your calculator out and you calculate 3/8, what do you get?
0.37.
0.375. So then to turn that into a percentage, it'd be 37.5%. Yeah? So we go fraction to decimal, and then from decimal, we move it back into a percentage. 2 2/5. How would you do that? Yeah, you could go into improper if you want. That's fine. So if you did, 5 times 2 is 10 plus 2 is, this would be 12/5. And then you could pull out your calculator and do 12 divided by 5. What do you get? 2.4. Then that would be the same as if we just did 2/5 separately, because 2/5 is 0.4. But the improper is fine. I don't really need a line there. Okay, now is that the answer? Is the answer 2.4%? That's not the answer. We haven't corrected for the fact that that's a decimal. It's 240%. Okay. So you go into decimal first, but then recognize you're dealing with a decimal, and then move it to be the percentage. The last one I gave to you was 1/50. So 1/50 is what? 0.02. And then as a percentage, though, what is that? 2%. So, yeah? All right, questions on any of those? Seem pretty straightforward. Okay. The thing I see people struggle with the most is remembering which way to move the decimal when. And so the way I always remember it is it's just like the percentage is going to be the bigger form, right? 25 is bigger than 0.25. The decimal is the smaller one. Okay. So then we can take once we know our decimal forms of our percentages, we can start using them to solve equations. So the ones that I had given you here. So first, so what number is 65% of 120? That was the question. Okay. All right, well, how do you solve a problem like this? Yeah. So what number we don't know is means equals. Percentages we always work in decimal form. Of means times 120. So you set up a percent equation, and then the equation tells you what to do. So to solve this equation, what do we have to do? This one's just multiply, right? X is already by itself, and we have 0.65 times 120 on the right-hand side. And so what do you get if you multiply it? 78, 78, 78. Okay. So that means 78 is 65% of 120. Seems reasonable, right? 65%, that's more than half. 78 is a little more than half of 120. That makes sense. Okay. So then we got what? Next over there, we got, say, 30% of 90 is what number? So sometimes it'll be written in a different order, and that's okay. We just still use our tricks. So 30% should be written as what? Yeah, 0.30 or 0.3. You don't need the 0 there, but 30% of means times 90 is means equals what number? We don't know. So the equation tells us what do we got to do? All we got to do is multiply. This one's the same. This one, even though it's written differently, it's actually the same question, more or less. It's the same type of question as the one above it. Okay. So then you got 0.3 times 90. What does that come out to be? 27? 27. So 30% of 90 is 27. Stop me if you have questions or you're not sure where any of that stuff's coming from. So then we got what? 12.5% of what number is 240? Okay. So then when you're reading a problem, this is why the equation is nice, because just reading that, it's not entirely clear to me whether I should multiply or divide. And then if I have to divide, what number gets divided by what? That's the hard part. And so, but when we turn it into equation, so 12.5% as a decimal, right? We move it over 2 places, so that'd be 0.25. Of means times. What number? We don't know. Is means equals 240, right? So now when we look at our equation, the equation makes it very clear to us what should we do to solve for that number. We need to divide by 0.125 on both sides. Okay? So it tells us that it's a division problem, and the equation tells us that the right way to divide it is to take 240 and divide by 0.125. So then we know which way to divide as well. So 240 divided by 0.125, it's actually going to get bigger. What number? Sorry, say that one more time. 1920? Okay, perfect. Would be your solution to that one. Okay, so you put in the equation, let the equation tell you what to do, and then you're good to go. Okay, another example says what? 80% of 175 is what number? Is this going to be a division problem or a multiplication problem? Oh, I already put the equals in there. It says is in the problem. Yeah, it says is in the problem, but okay. All right. So 80% is 80%. Of becomes times 175. Is equals what number we don't know. This is just a multiplication problem. So then 80%, 175, what's going to be? 140? 140. Those ones are nice and easy when it comes out just to be multiplication. Okay, the next one said, what number is 13% of 69.5? What does that one come out to be? Is that going to be a multiplication or a division problem? It's going to be multiplication. What number is 13% of 69.5, right? When we translate it. Again, yeah, this one's not too bad. It's just a multiplication problem. So you just do 0.13 times 69.5. What do you get? 9.035. Anybody else get the same thing? Perfect. All right. Then the next one, what we got? 125% of what number is 230? All right. So 125%, that's 1.25. Of means times. What number we don't know is 230. So how do we solve this? It's a division problem, right? Divide by 1.25, divide by 1.25. So then our answer is going to be whatever 230 divided by 1.25 is. And what does that come out to be? 184. Sounds reasonable. Other people get that? Perfect. There you go. Okay. Actually, I wonder if I started the recording on here. I don't think I did. Oh, I am. Perfect. Sweet. I'll go back to that now. All right. What questions do you have on those? So if it's set up like as an is of question, it's pretty straightforward to solve them. You just turn them into equation. The equation tells you what to do. Okay, not too bad. The problem is that typically, if you're actually working with percentages, it's not framed in an is of question, or is at least not exactly framed that way. And so that's where things can get a little bit trickier. Tax is usually pretty straightforward, so I did put a tip or tax example down here on the thing. Most people have familiarity with using tax and tips, so the idea was that you get a bill at the restaurant and it comes out to $43.78, and then you're going to go and you want to tip a certain amount. So let's say you want to tip 18%. Okay, then my question to you is, what should be your total bill? How do you calculate 18% of the bill? Well, what do? First off, we need to figure out, okay, well, first off, what is 18% of 43.78? So that'll give us the tip, and then once we know the tip, then we can get the total, right? So how do you do it? Yeah, anytime you're trying to do percentage of a number, right, the of is the key word. So the tip is going to be 18%, 0.18 times the bill, all right? And then that comes out to be what? 7.388. Is that rounded or is that 88888? 883? Yeah, whatever it goes. No?
That's right.
7.8804.
All right, well, we'll just go there. We don't actually have to go that far. We really only have to go out to there, right? Because we're talking about money, so we just need to round it to the nearest cent.
There's no three.
There's no 3?
No three.
Oh, I see. I got rid of the wrong 3. There was no 3 at all. I don't know why I got. You said 8803? 04. Yeah, okay, you know what? It's all good. The point is, it comes out to be what? 788? Yes. $7.88. There you go. That's your tip. How do you get your total? Well, your total is just what? Your bill plus your tip. Boom. And then whatever that comes out to be, was that 51? 51.66. Yeah. There you go. All right. Makes sense. Is there another way to do that problem? Anybody know another way to do problems like that? So this is actually, when you're finding like an after-tax tip price or an after-tax price, this can be thought of as a percent increase problem. Because if you think about it, like your final cost, right, it's going to be equal to the total plus 18% of the total. Right, that's how we ultimately added it, right? And so, well, if you think about, so what was it? It was 40. It was 43.78 plus 18% of 43.78. That's what we ended up actually adding, right? So one thing we haven't really covered the distributive property or anything like that yet, but one thing, this right here, you can think of 4378. This is 100% of the total, right? And this is 18% of the bill, right? So what you're doing basically is 100% of the bill is how much you have to pay anyways, and then you're tacking on 18%. So what you're actually spending at the end of the day is you're spending 118% of the bill. And so you can actually rewrite this. This is another way to think of this is 118% of the bill, which would be 1.18 times the bill. So try that in your calculator. Do 1.18 times 43.78, and what do you get? 51.66. Yeah. So you can actually, you can do this for tax as well. This trick will work. So like if you have an item that, I don't want to erase that. I just want to get rid of that line. So let's say that you have an item and it's $254.99. And then you're trying to figure out how much it'll be after tax, and say tax is like 8.6%, which, because that's what it is in Benton and Franklin counties, right? You can actually just take 1.0, you just tack the tax percentage onto 1. You can do 1.086 times the cost, and it'll give you the after-tax price. So something that's $254.99, you multiply it by 1.086 because that's the price plus 8.6% tax rate. And then what does that come out to be? Any takers? Somebody do that for me. This is what happens when I just make stuff up. I don't know the answers. So 276 point. Let's round is that even?
92.92.
Yeah, 2 decimal places because we're talking about money. So you said 276.92 if you. So it gets you straight to the after-tax price. You could do it in 2 steps, like you could calculate 8.6% of the value and then tack it back on to 254.99. But you don't need to. You can actually just do it in 1 step as a percent increase problem. So it'll work for TIBS, works for tax. Anytime you're basically tacking on a percentage to anything, it'll always work that way. All right. Okay. This will. I don't know if I really want to go there, actually. Okay. You can actually do a similar thing if you're doing percentage decreases as well. Because think about it the other way. Let's say, so I'm kind of moving on to section 6.3 is all about sort of applications of percentages. So then if we had, for example, let's say it was the other way. Let's say that an item that normally costs $254.99 is on sale for, let's say, 20% off. Or, yeah, 20% is fine. Okay. Then if you want to calculate the new cost, how would you do that? So what do you do for a decrease? You divide. We'll still end up multiplying. So one way to do this would be to multiply what? 20. If you multiply 20% by that number, what's it going to give you? I mean, I know that it'll give you a number, but what is that number going to be? Like, so yeah, so if you do 254.99 times 20%, right? Then you said what was the number? 50.998 whatever. Just 998. Okay, perfect. So if we're talking about money though, let's say we'll round, everything should be rounded to cents. Okay. Then actually what would happen to that 9? The 9 would round up to 10, but then what would that do? It would roll up to the next one, and that would roll up to there, and what would it actually round to? Yeah, it'd actually round up to $51. Yeah, because when you round, if you have a 9 that rounds up, it rolls over into the next category, but then if the next one's also a 9, it's going to roll over into the next place value. It'll just keep rolling until you get all the way. Okay, so it'd be, now what is that though? $51 is what? That's not what you're going to pay, is it? That's the what? Yeah, that's the discount, right? And so then the final price, we need to do what? Yeah, it'd be $254.99 minus $51. And so then the new price is going to be what? $203.99. Yeah? So that's one way you could tackle this problem, because it's like, oh, okay, I know it's 20% off, I'll find 20%, and then I'll just take it away. But you could actually treat this sort of like the percent increase problem, but instead this is a percent decrease problem. So if you think about it, right, the final price that you pay is like the original price minus 20% of the original price. True? I'll put it in blue. This is 100% of the price. This is 20% of the price. So it's like we're taking 100% of the price and we're taking away 20% of the price. That's how you could sort of conceptualize this. Now, So then really, if you have 100% of something and you take away 20% of something, well, what are you left with? If I have 100% and I take away 20%, what percentage am I left with? You're left with 80%. So another way to think about a 20% discount is to think of it being 80% of the actual price. So you could calculate the discount first, like the 20% discount, and take it away. Or you could say, hey, I know once I take 20% away, I'm going to be left with 80% to pay. I have to pay 80% because I'm taking away 20. So then we could actually get straight to the answer by calculating 80% of that original price. And if you do it that way, what do you get? Plug in your calculator. What's it come out to be? 203.992, which rounds to 203.99. So when you're doing percent increase or percent decrease, you can actually, you can do it as a two-step process. There's nothing wrong with that, right? Calculate the percentage and add it if it's tax or tip, or calculate the percentage and subtract it if it's a discount. There's nothing wrong with that. But you can actually shortcut those processes into a one-step process by saying, hey, I'm taking away a percentage, which means I'm going to be left. I have a leftover percentage, so I'll just calculate the leftover percentage instead. So if you go into the store and it says 15% off, okay, well then I know that I'm going to have 85% left, so I can just calculate 85% of the cost, and that'll tell me the after tax or after discount price. Okay, but either way is fine. It's not like there's like a wrong way or a right way. It's just more steps or less steps. Questions on that example? Okay, most people are pretty good at calculating like tax and tip and calculating discounts because I think we all do that at some level throughout our lives. Okay, because we interact with percentages a lot in that way. Sometimes it's not quite as straightforward. So like, let's say for example, I gave you a different type of information. Let's say that you end up paying, and I'm going to make this up, so let me make sure it doesn't turn into a disaster. So let's go. Let's say you pay, not paying, but you pay $3.76 in tax on an $80 purchase when you're visiting another town or like visiting another state. Okay. What I'd like to know is what must be their tax rate? That could just be pay. Okay. So in this case, I don't know the percentage, but I do know how much I paid. So how are you going to calculate the tax rate? Anybody got an idea?
Cardinal say you subtract 376 from 80 and it gives you total, and then.
I see what you're saying. Let's say I should clarify. I meant that. Let's say that your total I meant that the total was like 80 plus that. So like this 376 is the tax on the $80 purchase. So it's not like your original purchase was 70 something and then added on. I should probably clarify that, but let's say that. So it's like whatever you bought was $80, and then 376 was the amount of tax that you got charged for it. So at the end of the day, you would have walked away spending 83.76. What I want to know. So now, what rate must have been applied to get that amount of tax on that amount of purchase? That's the question. Any guesses? So think about on the worksheet that we just went through, I was talking about like is of equations. You can boil this down into like an is of percentage question. What are we really trying to get at? What are we really trying to figure out? This number is what? What are we really trying to figure out? Because in the is of equation, it's always like something is some percent of some number, right? That's like the form, right? So which one of those is a percentage of the other?
So would you turn 3.76 into a fraction? Because that's the percentage.
It's not a percent. So 376 is a dollar amount, though. We're trying to find the percent. See, that's what we don't know, right? See, the percentage is the unknown value. Okay. What we have is two dollar amounts, but which one is a percentage of the other? Is 80 a percentage of $3, or is 376 a percentage of 80? Right. So 376 is some percentage of 80, right? That's the way we could frame this as an is of equation. That's essentially what we're trying to figure out. 376 is what percent of 80? Okay. Well, if you turn that into a equation, so 376 is what percent we don't know of 80, it looks like the right way to solve this problem is to do what? Divide, and you should divide what number by what? Yeah, you should divide 376 divide by 80. And what do you get if you do that? And let's say, anyways, what do you get? I don't think we need to round it. 0.047. Is that a reasonable answer? Not the way it's displayed, but remember, is that what form, if you actually do division of fractions, you're getting decimals, not the percent form, right? So what do we need to do? So what happens is this right here, what it's doing is this is the decimal form of our answer. It is the right answer, but it's in the decimal. So what do we need to do to correct? And it looks like the answer is 4.7%. Okay. So if you're trying to calculate, so if you know the amount, but you're trying to figure out what percentage that is of some number, it's a division problem. Sometimes people will think of this as like, they'll try to parse out like what's the part and what's the whole, something like that. Okay. And it's always like part divided by whole. That helps some people think about it. It's like you take this, like in terms of tax or commission rates or anything like that. It's like that the tax or the commission rate is going to be the smaller number because you're not going to pay more in tax than the actual value of the bill, and so you just take the small number divided by the big number. For tax and commission, that typically always works. Okay. Questions about that one? Okay, so we could do a commission one. I'll give you an example of a commission one. See what you think about that. Let's go. Let's say that on a. Let's say that. Actually, let me rephrase that. Let's say that a salesman sells a vehicle. Okay, so let's say a salesman sells a car for let's say $12,000. Okay, and then let's say that on that $12,000, he earns a commission of $216. Done. Okay. My question is, what is the commission rate? What do you think?
Would you do 216 divided by 10?
Yeah, this is pretty much just like the last problem, right? What we're really trying to figure out here is 216 is what percent of 12,000? And so if you set it up as an equation, you'll see that the answer is going to, of is times, the answer here is going to involve dividing the small number by the big number, right? So you just take 216 divided by 12,000. What does that come out to be? 0.018. And then you just have to remember that that's the decimal form, right? When you're calculating these percentages, when you do division, it'll spit out a decimal, and so we just need to correct for that, which is we need to go back and move it over. And so it looks like it's 1.8%. All right. Okay. So if you're given a percentage in your problem, then you need to convert it to a decimal first and work with it. But if you have a problem where the percentage is the unknown value, you're going to do your calculations and end up with a decimal, so you have to convert back into that percentage form. So it just depends on what information you start with and what your answer is going to be. So you just have to pay careful attention. If the question is obviously asking for a percentage, just remember that at the end you're going to get a decimal that needs to be corrected. Right? Okay. All right. So far, so good. Everybody feel okay about that? All right. All right. Actually, I think that's good. I think I have enough here to give you guys this. Let's go. I got some practice problems for you to try on these. There's two at the bottom that we didn't do ones exactly like, but I think they're worth giving a try. I think you can actually. I don't think you'll have time to finish it before you go.
So this is nice, and what you just need to see this is like for the.
What's that? 12:15. Yeah, I don't think I'll have time to do them and go over them today, but so I'll go over these at the beginning of class tomorrow.